All right, so this is video number 2 now, where we're going back over the homework, the solution to the homework. I've already gone through the solution to the homework. The point values are going to be the same down to the point where we start to put in the value for R down here. N is worth a point. Having N equals 2.8 or 28.2 moles, that's all worth a point. The temperature, where we're showing that we've converted to Kelvin, that's worth 2 points. If they don't show both temperatures here and they just show 308.2 K, you can give them the 2 points because obviously you had to do the addition over here to get to that. But this is worth 2 points. If they showed their work, it's always required that you show your work. So the 1 point is for doing the addition. The other point here is for the correct rounding, getting this answer. Volume, V equals 127.4 liters. That's worth a point. The P equals a question mark. That's worth a point. Having R equal to one of these 4 values. They don't have to have all 4. Just one of the 4 values. In this case, we're going to solve for this one. Okay. So if they got that written here with the units, they have to have the number and the units of measurement there written correctly. That's R, and that's worth a point if they have all that. If they have the ideal gas equation written without any substitutions for values, PV equals nRT, if they wrote that, that's worth a point. Okay. Now we're ready to go and substitute in the R. Since we have a new version of R here, this is going to be 62.37 liters times millimeters of mercury over Kelvin times moles. Okay. Plugging that in there. So that's going to be worth a point where they're plugging that in there. It's going to be worth a point for writing P here, keeping P because there's no P in our list of knowns and unknowns. That's worth a point. Writing in the value for the volume, that's worth a point. Writing in the value for N here, moles, that's worth a point. Writing in the value for the temperature, that's worth a point. Okay, so now we're ready to get to that. We're at that point where we can go through our list of steps for solving. Okay, we've plugged in the known values. We're ready to isolate the unknown. So to isolate P, that's the unknown. That's the only variable that doesn't have any numbers written in for it. We need to be able to undo the multiplication between P and 127.4 liters. And you undo multiplication with division. And we can do that by writing a fraction with the reciprocal of this number. So 127.4 liters. What this is going to allow us to do is to take this number and divide by that number. By putting this over 1, then, we can clearly see, if you've been following along with the way I've taught you to do these things, that this entire section cancels. Okay? And writing that reciprocal there with the units of measurement is worth a point. They don't have the units of measurement, they don't get the point. They don't have the number, they don't get the point. They have to do it correctly. All right? Now, over on this side, if we did something to this side that's new, we also have to do it to this side. So I have to multiply by the reciprocal over here. 1 over 127.4 liters. Okay, and we're now at the problem-solving step where we want to cancel units. We're solving now. We're ready to solve. To see clearly what units can be canceled, let's put both these numbers over 1, both these measurements over 1. And I can see I've got a mole on the top and a mole on the bottom. We can cancel those. Kelvin on the bottom here and a Kelvin on the top here. Those can cancel. Liters on the top here and bottom here, I can cancel those. So I can see clearly now that I've got units of measurement of millimeters of mercury. And if I look on the front page of my test references, I can see here under pressure that one of the measurements of pressure that's acceptable is millimeters of mercury. Okay? So this is millimeters of mercury. It does measure pressure, so we know that we have a matching pressure unit with the let me think now, what did I call it a while ago? Dimension of measurement. P is the dimension of measurement. So the dimension matches the units of measurement. Okay? All right, so now we're ready to go about solving the problem. We know that we've set it up properly because our units match the dimension. We're ready to do the math. You multiply this number times this number times this number, all the things on the top, hit equals, then divide by this number on the bottom. Okay, and let's see, this is 4 units of millimeters of mercury, and the answer, the unrounded answer for this, pressure equals 4104.00 .4747 millimeters of mercury. Once again, we've got 3 significant digits in this number. All the others have 4, but we want our final answer to have the same number of digits as the least precise measured or calculated number. So we've got to underline everything after the first 3 digits. Okay? All right. This is one of those situations where I'm deleting or rounding off a number in the ones place. And the only way to write the correct answer here is in scientific notation. The only way you can write the correct answer is in scientific notation. So what we're going to do is we're going to move the decimal place 1, 2, 3 places. And so when we round this off to 3 digits, we get 4.10 times 10 to the third. If I move the decimal place 3 places to the left, it's times 10 to the third power. And that's millimeters of mercury. And so that's our final pressure using millimeters of mercury. Okay. All right. So let's go now to the next R value. We can plug into this. All right. Remember, this whole thing is going to be worth 20 points. Let's just be sure here. This has to be worth a point here. Canceling all the units properly. That's worth 2 points. And our unrounded answer with the correct underlining is worth a point. The final answer with the units of measurement is also worth a point. So that should be a total of 20 points. And that's not your bell. Just when I'm recording this, the bell happened to ring. Okay? All right, so we've done the calculation for this value of R. We've done the calculation for this value of R. Let's go and do the calculation for this value of R. And if you've been following along, you should be able to do all the measurements, or all the point values correctly up to this point. A point for N equals in the number and the units. 2 points for the temperature. 1 point for the volume. 1 point for the pressure. A point for adding and a point for rounding here to convert to Kelvin. A point for having one of these 4 versions of R. In this case, we're looking for this one. A point for having the correct, having chosen the correct equation to use and writing it down. A point for writing P over here times and this number with the units of measurement. You have to write the units of measurement. That's worth a point. Without the units of measurement, if they just have a number, that's not worth anything. Okay? Same here. Any of these numbers without a unit of measurement, they're useless to us in science. Okay? You're going to have a point for this. All right? What we want to do now is simply plug in this number right here. 8.314 liters times kilopascals. kPa is kilopascals. Over Kelvin times moles. All right? Same process. Multiply by the reciprocal in order to isolate the unknown here. Put this over 1 as well. Give that a point. Cancel all of that. We've isolated the unknown here. Whatever we do to this side, we've got to do to this side. So we multiply by the reciprocal over here. I'm going to put everything over 1. Just to make it easier to see what units we can cancel, give that a point. All right, now we go through and cancel all the units we can cancel. When we cancel everything, we see we've got kPa. Look on the front page of your test references and see that's an acceptable pressure unit here, kPa. And so we know that kPa is an acceptable pressure unit for the dimension we call pressure. So we're going to give all the cancellations worth 2 points. Going to give all the cancellations 2 points. It's worth 2 points. Okay. Now we want to write our unrounded answer. And the unrounded answer is 5P equals 547.0690311 kPa. Okay. we want to look and find the measured or calculated number in the problem with the least digits. Ones are not measured or calculated. Those are placekeepers or counting numbers. So the number with the least number of digits is this one, or the measured or calculated number of least digits is this one. We want the same number of digits in our final answer, 3. Underline everything else and round it off, and we have P equals 547 kPa. And there's your final answer, 547 kPa. Okay? All right. So that's the solution for this version of R. And we've got one more to go. And it turns out that if you are looking carefully, you can see that these two values are the same. That's because millimeters of mercury and torr are the same thing, actually. So all the work we did when we figured out the answer in millimeters of mercury will be the same work that we're going to do for torr, only in this case it will come out with units of torr when we're done. All right, so I hope you're paying attention. 1, 2, 1, 1, 1 point for adding, 1 point for rounding off, 1 point for the correct version of R, this one. We're going to plug that version of R in. 62.37 liters times torr over Kelvin times moles. Multiply by the reciprocal over here, 1 over 127.4 liters. Put it over 1 there, and we can cancel everything. Okay. We're going to give a point for having the P here, for the 127.4 here. Multiplying by the reciprocal is a point. If we or add something or multiply something on this side that's new, we also have to do the same thing to the other side of the equation. So over here, I'm going to multiply by that 1 over 127.4 liters. And that's all these values, putting these in the equation, that's worth the point. So is this unrounded or unplugged in equation, the raw ideal gas equation. Each of these things are worth a point. Now we're going to add a point for this. Put everything over 1 that we don't already have in a fraction. Cancel the units. This is going to be worth a point too. Okay. So, or actually 2 points. Cancellations are worth 2 points. Okay. Do the math, and we'll get that same number we had earlier when we were calculating for millimeters of mercury. 4104.004747. Torr is what we have left. Oh, and you can also check, you should also check, torr is one of the acceptable pressure units. Look on the front page of your test preferences, and there's torr. Okay. All right. Underline everything but the first 3 digits because this measured or calculated number has the least number of digits. And you've got to round it off using scientific notation here in order to have 3 significant digits. We find that pressure is equal to 4.10 torr. Use an arrow to show it's rounded off. This is the final answer. Both the unrounded answer with the units and the final answer with the units are worth a point for a total of 20 points for this one as well. All right, so you're going to add up all your points. Remember, you're going to put your points at the top of the paper, and you're going to allow the person whose paper you're grading to see their grade, to look over the corrections you've made. And remember, you have to do the corrections. And then you're going to pass your paper up to the substitute, and the substitute then will collect everything, and then we'll go on with the rest of the lesson for the day. So this will be the end of video number 2, and I'll ask the substitute now to look for video number 3.